Hi everyone, it's Miss Longarage here. Today I'm going to make a video about triangles and about how you can place a triangle on a graph and then do some math with that triangle that's on a graph or on a coordinate system. So let's look at an example together. Here is the example we're going to look at today. It is a triangle ABC, and it is on a coordinate plane. And it has 3 vertices. The vertices are at 1, 1, at 3, 5, and at 5, 2. And we want to do some math with this triangle that's on a coordinate plane or that's on a graph. I've drawn the example on chart paper. So here we have 1, 1. This is 1 and this is 1. So this point right here is 1, 1. I should say this is plus 1. And then this point right here is 5, 2. And this point up here is 1, 2, 3, 3, 5. And we can do some great math with this. So today we're going to learn a brand new formula. And the formula is called the distance formula. And the distance formula is this. D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. So this is a formula that we will use repeatedly this semester, just like we're going to use that formula m is equal to y2 minus y1 over x2 minus x1. And this D formula, the distance formula, will tell you how far apart these 2 points are, how far apart these 2 points are, and how far apart those 2 points are. It will tell you the distance between the 3 points. So let's first find the distance between 1, 1 and 5, 2. And just so that we don't get confused, I put 1, 1 in the table and I put 5, 2 in the table. And then we're going to use this equation. So this equation says I'm going to subtract my first x minus my second x minus my first x. So I'm going to go 5 subtract 1, which gives me 4. And then over here, I'm going to have to do my second y minus my first y. So 2 minus 1 gives me 1. So let's see what we get. We get D is equal to the square root x2 minus x1. x2 minus x1 was 4. And the equation says I have to square it. So 4 squared. And then I have y2 minus y1, which was 1, 1 squared. So I end up with 4 squared is 16. 16 plus 1 gives me the square root of 17. So that means that the distance between these 2 points is square root of 17. Let's try the next points. Okay, so if I have the next points, okay, so I want to go between 5, 2 and 3, 5. So I'm going to put those numbers into my table of values. So I have 3, 5, and I have 5, 2, and we know we're going to have to subtract. That's part of the formula. So let's subtract. 2 subtract 5 is minus 3. 5 subtract 3 is 2. We're going to write our formula again. Our formula is D is equal to x squared minus x1 squared plus y2 minus y1 squared. So we have, first when we subtracted the x's, we have 2. So I have 2, and I have to square that. Plus my y's when I subtracted them were minus 3 squared. So I end up with 4 plus 9 gives me square root of 13. So that means the distance over here is the square root of 13. Last but not least, we need to find the square root, not the square root, the distance between these last 2 points. So I'm going to make a table of values one more time. X, Y. My points are 1, 1 and 3, 5. 1, 1, 3, 5. I know I need to subtract. 5 minus 1 is 4. 3 minus 1 is 2. I'm going to write my equation down. D is equal to x2 minus x1 squared plus y2 minus y1 squared I did my subtracting already. When I subtracted my x's, I got 2. So I need 2 squared. And then y2 minus y1 is 4. So I have 4 squared. So I end up with 4 plus 16 is equal to the square root of 20. So that means this distance right here is the square root of 20. So if I wanted to find the perimeter, perimeter means what is the distance around the entire shape. I want to add up all 3 sides. So the first side we did was square root of 17. The second side was square root of 13. And the third side we did was square root of 20. And you can take a calculator and you can change that if you like to a decimal. And I'll do that right now. Use Siri. And I found out that when I add up those 3 sides, I get that the perimeter is about 12.2 units. So that's how you find the perimeter. Now when we find the perimeter, or when we look at the shape, is this shape, there's 3 choices. Is it equilateral? Is it isosceles? Or is it scalene? Those are 3 different types of triangles that we need to talk about right now. So this is an example of an equilateral triangle. An equilateral triangle is a triangle where all the sides are the same. All the sides are equal, and actually all the angles are equal as well. That's one type of triangle. The next type of triangle is an isosceles triangle. This is what an isosceles triangle looks like. It's a triangle where only 2 of the sides are the same and 2 of the angles are the same. So if you have a triangle where 2 sides are the same, it's called an isosceles triangle. And the last type of triangle we're going to think about today is a scalene triangle. A scalene triangle is where all the sides are different. So right here we have a triangle where one side is 13, one side is 9, and one side is 14. None of those sides are the same, so it is scalene. What we want to do is we want to go back to our triangle that we drew on a coordinate plane and see, is it isosceles, is it equilateral, or is it scalene? Here's our triangle again, and you can see that one side is square root of 13, one side is square root of 17, and one side is square root of 20. None of those sides are the same. None of them are equal, so this means that this is a scalene triangle.